Hello, today we're going to be solving a homework problem. Specifically, we're going to be finding the Laplace transform of this piecewise function. To get a better idea of what this looks like, I've graphed this piecewise function. So here, from 0 to 3, I get the point. 0 to 3, this function is just 0, and we can see that here when when t is between 0 and 3, it's just 0. And from 3 onwards, it will be the function t minus 3. So we can see that here. At 3, it changes to a different function. One thing to note right here, 3, 0, both these functions are 0 at this point, so this piecewise function is continuous. So next, we want to find the Laplace transform of a piecewise function. First, we know the definition of a Laplace transform is just the integral from 0 to infinity of our function times e to the negative st dt. And with a piecewise function, you just do the same thing, just in pieces. So we'll integrate from 0 to 3 for this function, and then from 3 to infinity for this function. So the Laplace transform equals the integral from 0 to 3 for e to the negative st times 0, plus the integral from 3 to infinity times e to the negative st times t minus 3. Keep in mind there should be a dt both these places. That must have been forgotten. So first thing of note, this function right here is a proper integral, so we can just solve that. So this simplifies to the integral from 0 to 3 of 0, and that just and solving that, we just get 0. So fairly easy, straightforward for the first part. The interesting thing here is the second one, which is an improper integral with infinity in it. So first things first, we have to, there's a little error here. Okay, we have to first take the limit as the letter I used is n. You can use whatever, but limit as n goes to infinity, an integral from 3 to n. And now we have to solve this integral. So I chose to solve this using integration by parts, and specifically the tabular method for that. So right here, I have, so d is the side you derive, t minus 3 derives to 1, 1 derives to 0. And then this right side here is the side you integrate. So e to the negative st, fairly easy to integrate. You just pull out a negative 1 over s each time. So then after we do that, we just pair up diagonally. And that gets us this right here. And we've solved this integral, so we get e to the negative st times 1 over s times t minus 3, and that's these two here. And then e to the negative st times 1 over s squared, and that's here. Next step is we have to solve this from 3 to n, because that's the endpoints of our integral. And that's, again, expressed here. So to do that, again, fairly straightforward. You plug in n everywhere in your equation, and then you subtract that from where you plug in 3 everywhere in your equation. Let's do this right side here because it is a little simpler. So this right here, 3 minus 3, this means this entire side simplifies to 0. And then that just leaves us the right side where it's minus e to the negative 3s over s squared. Fairly straightforward. This left side, though, there's 3 points of interest here. So e to the negative sn and minus 3 and e to the negative sn. All 3 of these points can cause our function to be infinite. So like if it was e to a positive infinity, that would be just infinity. And same thing over here. And n minus 3, that's going to be infinity either way. Important thing to note, though, e to the power negative sn, that's exponential growth, whereas n to the minus 3 is linear growth. And exponential is greater than linear, so we can just focus on those e powers. So negative Sn, we know if s is a positive value, this will stay negative, and e to a negative infinity would just be 0. So as long as s is greater than 0, this entire left side simplifies to 0 minus 0, because e to the negative Sn is on both sides. So this entire side simplifies to 0, and we just subtract by our right side. Here's where you would bring in, so our proper integral from 4, it's just 0. So it doesn't change our final answer, but in different problems, if this was a different value, it would change, so don't forget about it. So 0 plus e to the negative 3s over s squared. And keep in mind, we have the condition s is greater than 0. So our final answer, the Laplace transform of our piecewise function equals e to the negative 3s over s squared as long as s is greater than 0. Okay, thank you for watching.